Good day, good day. All right, y'all. So, today our asynchronous lesson is going to be a little bit different and a little bit, hopefully, more interesting. It is going to be about rational functions. So, today we're talking about rational functions. And what's going to happen in this video is that throughout the video, I'll have questions directed at y'all. What I'd like you guys to do is on your note paper, answer these questions and make sure to provide kind of like showing either your work or provide explanation for your answers, justify your logic when you're answering these questions. There's going to be about 4 of them. And then when you go to turn in this classwork, you'll just submit scans of your notes with these questions answered, please. So if we're going to be talking about rational functions, it will be useful for us to start off by thinking about rational numbers. So a quick recap about what are rational numbers. Rational numbers are the set of all numbers which are in the form of a ratio of integers. So let's think about what that is. A ratio means to divide. So essentially, rational numbers are just any numbers that can be written as a division of 2 integers. What are integers? If a and b are integers, that would be some numbers that are just like whole numbers, like 2 or -3, right? It could be a negative number. It could be a big number, like 48. Any whole number that you can think of is an integer, positive or negative, including 0. So rational numbers are just these whole numbers being divided. So it's just like the set of all fractions, basically, right? So some examples of rational numbers would be numbers like 2/5, -3/2, 6/1. And in fact, if 6/1 is a rational number, that's equivalent to 6, right? So even whole numbers like 6 are technically rational numbers as well. So that's actually kind of interesting. Rational numbers, like any number that's an integer, like 2, -3, and 48, is also technically a rational number because it could be written as just that number over 1, right? As a little quick side note, while we're talking about rational numbers, just to address what are irrational numbers. Irrational numbers are numbers which cannot be written as a fraction of integers. This would be numbers with like never-ending decimals, like pi. You remember pi is like 3.14 ... or something like square root 2, where square root 2 is also one of those decimals that goes on forever. It's something like 1.41 ... So rational functions are very similar to rational numbers because they are defined as any function with a ratio of polynomials. So a rational function is a function with a ratio of polynomials. Polynomials are what we've been learning all about recently. If you guys remember, polynomials are functions of the form p of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, and it goes like that until you get to the constant a sub 0. Essentially, remember, this is just the idea that a polynomial is any sort of function with just a series of x's of different powers adding each other. So let's look at rational functions. Rational functions are defined as a ratio of polynomials. So that would be a function of the form p of x divided by q of x, where p and q are both polynomials. All right. So some examples of rational functions are just anything where you have 2 polynomials dividing each other. For example, here's my first example, 2x squared plus 3x minus 1 all over x plus 4. Here I have one polynomial divided by another polynomial. Pretty straightforward. Another example of a rational function. Technically, the number 1 or any number on its own is a polynomial, right? It just is a polynomial of degree 0. That's what we would call that, degree 0. Remember, degree is the power of x. And if I have a number, then there is no power of x. So that's why it's degree 0. So an example of a rational function could be 1 over x squared plus 3x plus 2, where I have a large polynomial on the bottom of my fraction. And my third example that I want to give you guys, this one here, 3x cubed plus 2x squared plus x plus 1 all over 1. So in fact, just like with rational numbers, a rational function could just be over the constant 1, which would essentially translate into this polynomial, 3x cubed plus 2x squared plus x plus 1. Essentially, what does that mean? It means that rational functions are very similar to polynomials, okay? In fact, even polynomials are technically rational functions. All polynomials, any polynomial that we've been working with so far, is technically a rational function. So for the first question of this series, I want you guys to use what we've discussed just now about the definitions of rational functions and what are rational functions to try to figure out which of the following 4 functions is not a rational function. 3 of these 4 are rational functions and 1 of them is not. When you choose it, I would like you guys to additionally explain why the one that you've chosen is not a rational function. Remember, guys, we are answering these on our notes. We're answering these questions on our notes and scanning those notes and uploading on the asynchronous assignment for today. Once you have decided upon an answer, go ahead and go to the description in the bottom of this video, and you'll find 4 links. Link A, B, C, and D. Based on the answer that you chose, select one of those links to go to the next video. So for example, if you thought that the answer was answer A, then you will click the link which has question answer A attached to it.